Hello dear student, how are you? I hope you all will be fine. I'm also fine. Let's start today's topic. Today I bring a new mechanism that is called Cannizaro reaction, Cannizaro mechanism. That is very important mechanism in organic chemistry. Mostly should be used in the BS students. They are used. Okay, let's start the mechanism of the Cannizaro reaction. In Cannizaro reaction, there are two types. There are two aldehydes react to each other in the presence of acid and base. Means this reaction is also acid catalyzed as well as also base catalyzed. Means acid base catalyzed reaction. So in the presence of acid base, in the presence of catalyst, they react with the one aldehyde will react with another aldehyde and produce some products. Okay, let's see the products. Let's start the mechanism to see the product. Okay, the first of all, that is benzaldehyde. That is benzaldehyde. That is benzene group or phenyl group. You can say phenyl. Phenyl, when they are attached with the aldehyde groups, that is C double bond O, and one on the another side of the carbon is that is H. So this group is called aldehyde. So benzaldehyde, when they are when first of all when strong base are used, when base are used, nucleophile will be attack on this carbon. Nucleophile will be attack on this carbon, that is benzene carbon. Nucleophile will be attack on this carbon, that is the carbon of the carbon aldehydes. So aldehyde carbon, that is are also called carbonyl carbon. So this carbonyl carbon, why they are attacked on the carbonyl carbon? Because carbonyl carbon, it is electrophilic in nature, because it are attached with the electronegative elements, that is oxygen, that is strong electronegative elements. So that's why it will be strongly withdraw the electron towards oxygen, toward itself. But on the carbon here, when the electron are donated towards oxygen, so that's why carbon will get positive charge, partial positive, oxygen will get partial negative charge. So that's why carbon will be act as a electrophilic. So that's why this nucleophile can be attack on this carbon. When they attack on this carbon, carbon has already completed their covalency. So that's why one bond should be break. So that bond will be break that are more polar. So the bond between carbon and oxygen, they are polar. So that's why this bond will be break towards oxygen and produce this types of compounds. That is benzaldehyde, that is same as before, that is C6H5H. Here is one OE group attached, but one bond will be broke towards oxygen. So that's why oxygen will get negative charge, and this product will be produced still. Once again, another carbaldehyde or benzaldehyde groups needed. So that is one another benzaldehyde groups, that is carbon C double bond OH, that is attached with the phenyl groups, another aldehyde groups. But here in this case, here is one oxygen negative elements, negative oxygen producer. So this why this negative electron, this lone pair, extra lone pair, can be attack bake on can be bake produce bonds, double bond. So that's why when they are produced double bond, here is carbon covalency already completed. So that's why one bond should be break. But here in this case, this bond will be break, and the carbon will be act as a carbon will be sorry, that hydrogen will be donated, or this hydrogen will be lose this compound, but is a hydride. The means hydrogen will be lose as a hydrogen negative. This bond will be shift here, this lone pair or this negative will be shift here, and here produce double bond, but this bond will be break. But here this is hydride is very reactive compound. So that's why that will be attack on the another benzaldehyde that are present in the solution. So that's why C6H5, that is one the same thing this before produced. So that is benzaldehyde. But when here is this arrow is wrong arrow, that was the blender of, that is the mistake of the book author. So that's why this negative charge attack on big attack on here and produce double bonds. So as the double bond become produces, here this hydrogen will be left this compound as a hydride, and will be attack on the directly, it will be attack on this carbon. When they are attack on this carbon has already completed their coaling. So that's why one double bond between a carbon and oxygen will be shift towards oxygen, and oxygen will be get negative charge, and here will be produce carboxylic acid, or you can say that is benzoic acid, because C double bond O and OH, that is benzoic acid, that is acid carboxylic acid group, and that is benzoic, that's why it will be called benzoic acid. Like that, that is benzoic acid. But this step will be very slow steps when the hydride formation, agar hydride formation is slow steps. But here also one another compound is produced, that is HC6H5, because one hydride when they left this benzoic acid, So that's why this hydride attack on the benzaldehyde groups. So here is 2H produced, two hydrogen that are bound with the carbon and bound with the oxygen negative, that carbon is also bound with the phenyl groups. But here in this compounds, these are two compounds produced. Here in these two compounds, the proton exchange will be occur, but this step will be very fast steps. For how proton exchange will be occur, that is one proton in this compound, in the first compound, that is benzoic acid. In benzoic acid, this proton is very reactive, means that this proton can be exchanged toward this hydrogen, but this reaction will be present, this reaction will be catalyzed by an acid. So that's why this will be acid catalyzed reaction. This hydrogen will be shift toward or exchange toward here toward this oxygen. When they are when they are moved towards this oxygen and attach with this oxygen, it will produce as a proton or as a electrophile. Hydrogen has positive charge and oxygen has negative charge, so that's why it will produce neutral molecule, that is HO, neutral groups, OH. So that's why C2H C6H5CH2OH, that will be bond produced, and it is also called alcohol. It is also called alcohol. So this why C6H5CH2OH, this bond will be this compound will be produced, that is alcohol groups. But here when this proton are moved towards here, but in this case here this oxygen will be get negative charge, so this negative charge will be stabilized by resonance in between these two molecules, these two atoms of oxygen that are bound with carbon. So sometimes this double bond will be shift here and the negative charge on the oxygen will move here, but sometimes this oxygen will be that means the double bond or the negative charge on oxygen will be localized and it will be resonance stabilized. So it will be produced like this. That will be sometime this negative charge will be on this oxygen when they are bonded, when they are produced double bond here. So here double bond will be produced, but this bond will be shift towards oxygen because carbon has completed their coiling, so that's why it will be get negative charge and this will be resonance stabilized. But once again you here in the presence of acids, in the presence of strong acids, this can be also produced carboxylic acid are also called benzoic acid. This is the concepts of Cannizaro reactions. I hope it will be cleared. Cannizaro reaction. Let's do on this let's do this mechanism for the simple aldehydes. That is one simple aldehyde RC double bond OH, that is not aromatic aldehydes. Before it was used aromatic aldehydes. That is C6H5, that is aromatic aldehyde, but in this case that is not aromatic aldehyde, but that is aliphatic aldehyde. In the presence of aliphatic aldehyde, the same mechanism will follow. The first of all, that one base will be attack on the carbon, that is carboxylic, that is electrophilic carbon, means that are in nature they are electrophile, they can be attacked on the nucleophile, can be attacked on this electrophile and this carbon because it is bonded with the more polar compound atoms, that is oxygen. The oxygen will be withdraw the electron, so that's why carbon will get partial positive charge and act as an electrophile. So here is the same mechanism as before I used. I hope it will be cleared. Still, if you have any confusion, if you have any question, you can ask me in comment section, as well as you can ask me in my personal WhatsApp or Gmail that I put in the description box. You can get from there. Okay, let's see this mechanism as in assignments and do practical work on this mechanism. Also take some another example regarding aldehydes. You can take any aldehyde or you can use this mechanism for formaldehyde. Okay, it is your assignment that this mechanism you can do, or can you do this mechanism for formaldehyde when you use formaldehyde is a substrate in this mechanism. Okay, thank you very much, very best of luck. Also please subscribe my channel, it makes me feel happy that my students are supporting me. Okay, thank you very much, very best of luck my students, very best of luck.